What if I told you there was a bug that looks like a delicate pink and white orchid, but hunts like a tiny precision-guided missile? Imagine a flower that could snap a cricket in half faster than you can say oops. That's the Orchid Mantis, and it's basically nature's way of saying, don't judge a bug by its blossom. Welcome to What Is, the channel that takes the weird and wonderful and turns them into bite-sized stories you can actually use at dinner parties. And today we're diving into the world of the Hymenopus coronotus, the Orchid Mantis, the walking flower, the floral fashion victim that also happens to be a ruthless predator. A flower with appetite. First things first, what exactly is an Orchid Mantis? Put simply, it's a mantid, part of the order Mantidea, that has taken mimicry to a whole new level. Instead of the typical brown and green twig vibe you'll find on most mantises, the Orchid Mantis wears striking pink and white, and sometimes even coral-colored outfits that resemble the petals of an orchid. Its legs are flattened and leaf-like, and its forewings often display a pattern that looks like a flower's veins. It's basically the insect world's answer to a runway model, gorgeous, photogenic, and lethal. Now you might think, okay, it's pretty, but why does it look like a flower? And the answer is aggressive mimicry. The Orchid Mantis doesn't just hide from predators, it actively lures prey by pretending to be a tasty nectar source. Insects, whether they're bees, butterflies, or flies, spot what they think is a flower, land on it, and snap. The mantis's raptorial forelegs tighten in a fraction of a second. In other words, it's the original fake flower scheme, and it works like a charm. If insects had Yelp reviews, the Orchid Mantis would have a ton of one-star notes about misleading advertising. But the mantis doesn't care. It's too busy feasting. Taxonomy and physical profile. Let's get a bit scientific, but keep it fun. The Orchid Mantis belongs to the family Hymenopidae, a group called flower mantises. Its scientific name, Hymenopus coronosus, roughly translates to membrane-footed crown bearer, which is a fancy way of saying it's got fancy foot pads and a crown-like head. Adult females are the showstoppers. They can reach up to 6 to 7 centimeters in length, that's about 2.5 to 3 inches, while males are considerably smaller, usually around 3 to 4 centimeters. The size difference is huge. In fact, if you put a male and female side by side, you swear they belong to different species. One of the most fascinating aspects of their appearance is their ability to adjust their color. While they're mostly pink or white, some individuals can turn a deeper orange-brown when they're on a darker leaf, helping them blend in even better. Think of it as the mantis's very own Instagram filter, except it's for survival, not likes. While here at What Is, I definitely like those likes. If you're digging this deep dive into the Orchid Mantis, we have more videos like this on our channel and more coming soon. Hit that like button, it really helps the channel blossom. See what I did there? Let's get back to the Orchid Mantis and look next at where it lives, the tropical real estate. The Orchid Mantis is a Southeast Asian native. You'll find it in the rainforests of Malaysia, Indonesia, Thailand, Myanmar, and even the Philippines. It prefers the humid, dense canopies of tropical forests, usually hanging out on the underside of large leaves or on low-lying shrubs where sunlight filters through. Its habitat choice is strategic. The forest floor can be a dangerous place. Lots of bigger predators, more competition. By living up in the foliage, the Orchid Mantis gets first dibs on incoming pollinators. It also has a built-in leaf umbrella that protects it from the heavy rains, because frankly, no one wants a soggy flower. The art of the hunt, predator in disguise. Now the juicy part. How does this flower actually catch its meals? The Orchid Mantis is a sit-and-wait predator. It perches on a leaf, stays perfectly still, and sways gently in the breeze, mimicking a blossom swaying in the wind. When a potential prey item, an unwary fly, a honeybee, or even a small moth, comes close, the mantis lunges. Its strike is lightning fast, 0.1 to 0.2 seconds, which is essentially the speed of a blink. The powerful forelegs, equipped with spines, clamp down and hold the victim in a vice-like grip. Then the mantis starts munching, using its mandibles to tear apart the insect, much like we'd eat a crunchy snack. Fun fact, the mantis doesn't even need to chase its food, it just needs to look pretty and wait. In the words of one etymologist, it's the world's most passive-aggressive hunter. Literally flower power with a side of murder. What's on the menu? The orchid mantis is what you'd call a generalist insectivore. Its diet includes flies, houseflies and fruit flies, moths and butterflies, crickets and grasshoppers when they're small enough, and occasionally tiny frogs or lizards that wander too close. In captivity, hobbyists often feed them fruit flies, small crickets, and even mealworms. But in the wild, they've been observed tracking prey up to twice their own body size. Imagine a tiny flower taking down a fat bumblebee. Now that's a viral video. Life cycle from egg to adult. Like all mantises, the orchid mantis undergoes incomplete metamorphosis, meaning it doesn't have a true pupal stage. Instead, it hatches a miniature version of the adult called a nymph. Egg stage. Females lay a frothy egg case called an euthachia, attached to a twig or leaf. This foam protects the dozens of eggs inside from predators and the elements. Nymph stage. When the nymphs emerge, they're tiny, wingless, and often resemble ants rather than flowers. This ant mimicry is a clever defense. Ants are aggressive and taste bad, so predators think twice before snacking on them. As they molt several times, usually 5 or 6, they gradually develop their iconic flower-like appearance. Adult stage. After the final molt, they acquire full wings. In females they're often reduced, while males have fully developed wings for flying. Adults live for several months, with females typically outliving males, a pattern we're going to revisit as we move on to talk about romance in the mantis world. Romance, reproduction, and a little cannibalism. Mating in the orchid mantis is as dramatic as you'd expect from a predator that also looks like a flower. When a male senses a receptive female, he'll approach cautiously, because, well, females are known to snack on males during or after copulation. It's a classic case of love is a battlefield. The male will perform a delicate dance, moving its antenna and wings to signal his intentions. If the female is in the mood, she'll allow him to climb on her back. If not, well, let's just say he might become an extra appetizer. After mating, the female lays her eggs and the cycle begins anew. While this cannibalistic behavior might be a bit gruesome, it's actually a smart nutritional strategy. The extra protein helps her produce healthier eggs. In the mantis world, romance can be a life or death situation. Predators and defenses. Even a master of disguise has enemies. The orchid mantis falls prey to birds, larger insects, reptiles, and sometimes even bats. Its primary defense is, of course, its flower mimicry. Most predators think it's just a harmless bloom. If discovered, it can also use a startle display, suddenly spreading its wings and flashing bright colors to frighten the attacker, giving it a split second to escape. Another clever defense is its ability to sway. By moving in a slow, rhythmic motion, it not only mimics a flower in the wind, but also makes it hard for visual predators to lock onto its shape. It's basically doing a gentle wave while thinking, "You don't see me, right?" Conservation status. Is the orchid mantis threatened? Currently, the orchid mantis is not listed as endangered or threatened by the IUCN. However, its rainforest habitats are under pressure from deforestation, logging, and agricultural expansion. As Southeast Asia's forests shrink, the mantis's home shrinks with them. In the pet trade, they're considered a prized species. Breeders often sell them for a premium. While sustainable captive breeding programs exist, illegal collection from the wild could become a concern if demand spikes. The rule of thumb, if you're thinking about getting one as a pet, make sure it comes from a reputable breeder who respects wild populations. Why should we care? Beyond the wow factor, the orchid mantis is a shining example of evolutionary creativity. Its mimicry isn't just skin deep, it's a complex hunting strategy that has inspired researchers studying robotics, camouflage, and even biomimetic design. Imagine a robot that can blend into a flower bed and snatch a fly. Sounds like science fiction, but the mantis already does it. Also, the orchid mantis sparks curiosity. People see a flower that moves and ask, what is that? And end up learning about ecosystems, predator-prey dynamics, and the importance of biodiversity. In that sense, it's an ambassador for the tiny, often overlooked insects that keep our planet humming. Let's boil it down. What is it? Hymenopus coronosus, a flower mimicking mantis from Southeast Asia. What does it look like? A pink-white orchid with leaf-shaped limbs, females larger than males. Where does it live? Tropical rainforests of Malaysia, Indonesia, Thailand, and nearby regions. How does it hunt? By posing as a flower, waiting for pollinators, and striking in milliseconds. What does it eat? Flies, moths, crickets, and occasionally small vertebrates. Life cycle: egg, ant mimic nymph, adult, flower-like. Conservation: not critically endangered, but habitat loss is a looming threat. Fun facts to impress your friends. Walking orchid. Some people call them walking flowers because they literally stroll around the leaf litter while looking like a blossom. Color shifting. They can adjust their hue from pinkish white to deeper coral, depending on the background. Swaying. The mantis gently sways to mimic a flower in the wind, a behavior that also helps it avoid detection by predators. Sexual size dimorphism. Females can be up to twice the size of males, making them one of the most size-distinct mantis species. Mantises in love. The male's approach is so risky that some researchers compare it to playing roulette with your own life. Final thoughts. The orchid mantis reminds us that looks can be deceiving, especially in nature. It's a living, breathing case study in evolution, showing how a creature that can turn its body into both a trap and a disguise. So next time you're admiring a beautiful orchid, pause for a second, because that flower might just be watching you back. Thanks for joining me on this floral-filled adventure. If you enjoyed this video, don't forget to like, comment with your own mantis tales, share this video with friends, and subscribe to What Is for more nature, science, music, and many other topics, because the world is full of what is moments waiting to be explored. See you next time. Welcome to What Is. Today we're diving deep into the trenches to answer a question that sounds simple, but actually involves a creature that defies the laws of physics, biology, and common sense. What is the mantis shrimp? Imagine, if you will, a creature designed by a committee consisting of a professional boxer, a psychedelic artist, and a high-end military weapons engineer. That creature is the mantis shrimp. But right off the bat, we have a problem. The name is a lie. The mantis shrimp is not a mantis. It's also not a shrimp. It's a stomatopod, part of the lineage of crustaceans that branched off from the others around 340 million years ago. That means they were doing their thing before the first dinosaurs even thought about showing up. They've had plenty of time to specialize. And oh boy, did they specialize. There are about 450 species of mantis shrimp, and they range in size from a few centimeters to about 38 centimeters, roughly the size of a very angry, neon-colored sub-sandwich. They live in tropical and subtropical waters, mostly hiding in burrows, and they spend their days either looking for something to kill or reimagining the physics of the universe. To understand what a mantis shrimp is, we have to look at their two most famous features, their eyes and their hands. Let's talk about the eyes first. Human beings are pretty proud of our vision. We have three types of color-receptive cones in our eyes: red, green, and blue. Every sunset, every masterpiece painting, every neon sign you've ever seen is just a combination of those three colors. Dogs only have two. Butterflies have 5. But the mantis shrimp, that has 16. 16 color-receptive cones. To a mantis shrimp, the world doesn't just look colourful. It looks like a multi-dimensional fever dream that we cannot comprehend. They see the ultraviolet. They see infrared. They can even see circular polarized light, something that no other animal on Earth is known to do. Their eyes are mounted on stalks and move independently. They can track two different objects at once in 360 degrees, while simultaneously analyzing the light spectrum for hidden predators or prey. Imagine if you could watch two different movies on two different screens while also being able to tell if someone was hiding behind the curtains based on the heat signature of their breath. That's just a Tuesday to the mantis shrimp. Scientists believe they use this incredible hardware to communicate through secret light signals that other predators can't see. It's like having a private, encrypted military-grade Wi-Fi signal, but built into your face. But as impressive as the eyes are, most people know the mantis shrimp for its punch. In the world of stomatopods, there are two main factions, the spearers and the smashers. The spearers are the ninjas. They have barbed, sharp appendages that they use to snag soft-bodied fish and shrimp with terrifying speed. It's classic slasher movie stuff. 1 second the fish is swimming, the next it's pinned by a set of serrated blades. But the smashers are the heavyweights. They have evolved a specialized dactyl club, a calcified bulbous appendage that they use to literally shatter their problems into pieces. If a smasher sees a crab, a clam, or a snail, it doesn't just try and find a weak spot in the shell, it just hits the shell until the shell stops existing. And it's not just a fast hit, it's one of the fastest movements in the animal kingdom. A mantis shrimp's punch accelerates at the same speed as a .22 caliber bullet. Their limbs move at 50 miles per hour underwater. In the time it takes for you to blink once, a mantis shrimp could have punched something 500 times. The physics here are actually insane. The movement is so fast that it creates something called a cavitation bubble. Because the punch is so rapid, it creates a localized zone of low pressure that causes the water to boil. When the bubble collapses, it releases a secondary shock wave. This means that even if the mantis shrimp misses the target, the shock wave alone can knock out its prey. When the bubble collapses, it also generates a tiny flash of light and a burst of heat that for a micro fraction of a second is roughly the temperature of the surface of the sun. Let that sink in. There's a shrimp in the ocean that hits things so hard it creates underwater fire and the heat of a star. If you were to put a large mantis shrimp in a standard glass aquarium, there's a very high probability it will simply punch its way through the glass, just to see what else is in the room. They are the only pets that require double-paneled high-density acrylic housing just because they are literally too much for standard physics. Now you might be wondering, if they hit things that hard, why don't their hands break? This is where evolutionary engineering becomes a miracle. The dactyl club is made of layers upon layers of chitin, arranged in a spiral or helicoid structure. This design acts as a shock absorber. When the club hits a rock-hard shell, the energy is dissipated through the layers, preventing cracks from spreading. In fact, the US military and aerospace engineers are currently studying the mantis shrimp's club structure to design better body armor for soldiers and more impact-resistant plating for spacecraft. We are learning how to survive high-velocity impacts from a 10-inch long rainbow crustacean. But what about their social lives? Are they just mindless killing machines? Well, mostly yes, but they have some surprisingly complex behaviors. Many species are monogamous, staying with the same mate for up to 20 years. They share a burrow, they raise their young together, and they defend their territory as a team. However, defending territory usually involves more violence. Mantis shrimp are notoriously grumpy neighbors. They engage in Telson sparring, which is basically a ritualized wrestling match where they take turns hitting each other on their reinforced tail sections. It's the crustacean equivalent of who can take the most punches to the stomach. The one who gets tired first usually leaves the neighborhood. The life of a mantis shrimp is also one of constant danger, primarily when they molt. Like all crustaceans, they have to shed that hard outer shell to grow. During this time, the smashing club is soft and useless. A mantis shrimp during the molt is essentially a defenseless piece of sushi. They spend this time hiding deep in their burrows, sometimes blocking off the entrance with rocks, waiting for their new armor to harden. If they are found during this process, it's game over. Despite being a nightmare for crabs and snails, they are incredibly important to the reef ecosystem. Since they are apex predators of the microworld, they keep the populations of other crustaceans in check. They are also indicators of reef health. If the mantis shrimp are thriving, the reef is usually doing well. Humans have a complicated relationship with them. In some parts of the world, like Japan or Vietnam, they are a delicacy. In Japan it's called shackle, and is often served as sushi. However, fishermen generally hate them. If a mantis shrimp ends up in a net, it can slice through the mesh, kill the other fish in the hole, and even slice open fingers of an unwary fisherman. They earned the nickname thumb splitters for this very reason. Beyond the dinner table, we are looking at them for medical breakthroughs. Because their eyes can detect circular polarized light, which is something that cancerous tissue reflects differently than healthy tissue, scientists are developing mantis shrimp-inspired cameras. One day a surgeon might use a camera based on these eyes to detect the exact margins of a tumor that would be invisible to the human eye. So what is a mantis shrimp? It's an evolutionary outlier. It's a creature that sees more of the world than we ever will, and interacts with that world by punching it into oblivion. It's a biological miracle that holds the secrets to better armor, faster cameras, and perhaps even the cure for cancer. It's also a great reminder that if you're ever snorkeling and you see a very pretty, very colorful shrimp looking at you with two googly eyes, you should probably give it some space. You don't want to be the person who got knocked out by a piece of seafood. Thanks for watching this episode of What Is. Did we miss any crazy mantis shrimp facts? Do you think you could take one in a fight, assuming it was the size of, say, a cat? Let us know in the comments below. If you enjoyed this deep dive, please give us a thumbs up and share this video with your friends. And if you haven't already, subscribe for more fascinating looks into the world around us. Until next time, stay curious. Imagine you're wading in crystal clear water. The surf whispers, "Come on in," and then, whoosh, a translucent pink-tinged balloon bobs past. You think it's a stray plastic bag, maybe a party decoration some kid ditched. But if you reach out to touch it, well, let's just say the ocean has a way of reminding you that curiosity can be a stinging quality. That, my friends, is the Portuguese man-o'-war, a creature that looks like a floating balloon, behaves like a sail-powered ship, and packs a venomous punch that could make a jellyfish say, "ouch," in unison. So what exactly is a Portuguese man-o'-war? And what on earth do we mean when we ask, what is a shoal of Portuguese man-o'-war? Stay with me, because we're about to turn that mystery inside out, sprinkle in some science, a dash of humor, and maybe a beach ball joke or two. Meet the Portuguese man-o'-war. First things first, the Portuguese man-o'-war. Physalia physalis for the Latin lovers among us isn't a single animal. It's a colonial organism, a tiny metropolis of specialized cells called zooids. Think of it as a condo complex where every unit has a job. Some swell up with gas to keep the whole thing afloat. Others dangle long, venom-laden tentacles to snag dinner, and a few even handle reproduction. If you've ever seen a jellyfish and thought, that's a floating sea ghost, The man-o-war is the fancier cousin who decided to bring its own sail to the party. The sail is actually a gas-filled float, a translucent balloon-like dome perched on top of a cluster of tentacles. That float can be anywhere from a few centimeters up to about 30 centimeters tall, depending on how much gas that tiny invisible crew decides to pump in. And talk about a big family. Those tentacles can stretch more than 10 meters. That's over 30 feet. They're lined with nematocysts, tiny microscopic harpoons that fire a cocktail of neurotoxins the moment something brushes against them. In other words, if you're a tasty copepod or an unsuspecting swimmer, you're about to receive a painful invitation to the ocean's most exclusive club. Now, why the flamboyant name? The Portuguese part comes from the 16th century warships called men-o-war, because the creature's sail resembled the outline of those imposing vessels. Add Portuguese because of its occasional presence in waters near Portugal, though nowadays they're found in warm seas worldwide. And war? Maybe because, as you'll soon learn, getting tangled in their tentacles feels like a battle you didn't sign up for. It's basically a tiny floating navy that never asks for a surrender. It just shoots first and asks questions later. Anatomy, habitat, and lifestyle. Let's break down the anatomy of this underwater marvel, and I promise we'll keep it as painless as the sting itself. Well, almost. 1. The float. A gas-filled bladder made mostly of carbon monoxide. Yes, the same stuff that makes a car exhaust feel not great. The float is topped with a small sail that catches the wind, propelling the colony across the ocean surface like a sailboat without a crew. 2. The tentacles. The real action happens below. Each colony has a network of tentacles that can extend horizontally for meters, each equipped with thousands of nematocysts. When a prey, say a small fish or a tasty shrimp, brushes by, those nematocysts explode, injecting a toxin that paralyzes the victim. The tentacle then reels it in, and the gastrozoids, the eating zoids, digest the catch. 3. Breathing? Not really. The man-o-war doesn't have gills. Instead, its soft tissues exchange gases directly with the surrounding water, so it basically breathes through its skin. Where do they hang out? You'll find these floating colonies in tropical and subtropical seas. The Atlantic, especially the Gulf of Mexico, the Caribbean, and the waters off the Azores, the Indian Ocean, and the Pacific. They love warm surface waters, typically between 20 degrees Celsius and 30 degrees Celsius. They're often blown shoreward by wind and currents, which is why they show up on beaches after a breezy weekend. A surprise you don't want to discover with a bare foot. Lifestyle highlights. They're drifters, not swimmers. Their float lets them ride the wind, sometimes forming massive slicks on the water's surface. They reproduce both sexually, releasing eggs and sperm into the water, and asexually, budding new zooids that stay attached. In a sense, a single colony can spawn thousands of new colonies over its lifetime, a population explosion that can turn a calm sea into a battlefield of floating stingers. Fun fact, the Portuguese man-o-war is not a true jellyfish. It's more like a hydrozoan, a closer relative of corals and sea anemones. So if you ever hear someone say jellyfish, you can correct them with a smug smile. Actually, it's a hydrozoan. Think of it as the jellyfish's more ambitious cousin who decided to build its own sail. If you're enjoying this deep dive into the world of marine critters and want more What Is stories, then hit that subscribe button and ring the bell. I'll see you on the next adventure. Next, let's look at the shoal concept. Now, what in the ocean lexicon do we mean by shoal? A shoal traditionally refers to a group of fish or marine mammals moving together, like a school of tuna, a pod of dolphins, or a pod of whales. It's a social term, implying some level of coordination, or at least a shared zip code. But here's where things get a little fuzzy for the Portuguese man-o-war. The word shoal is sometimes used colloquially to describe any aggregation or bloom of these critters. When the wind picks up, dozens or even hundreds of colonies can cluster together, creating a shimmering carpet of floating bubbles that stretches for miles. Fishermen have long referred to these gatherings as shoals of Portuguese man-o'-war, even though scientifically we'd call them an aggregation, bloom, or simply a group. Why do they bunch up? Several reasons. Wind and currents. Their sail-like floats catch the breeze, so when the wind blows in a consistent direction, colonies end up drifting together, like leaves gathering in a corner of a pond. Feasting. A dense cluster can increase the chances of catching prey. Think of it as a buffet line, where each table, the tentacles, is ready to snag whatever floats by. Reproduction. When multiple colonies are in close quarters, sexual reproduction becomes easier. They can release eggs and sperm into the water simultaneously, boosting fertilization odds. So, a shoal of Portuguese man-o'-war is essentially a wind-driven aggregation of dozens to thousands of colonies, forming a visual spectacle that can be beautiful and dangerous at the same time. It's like a beach party, where the guests are all equipped with tiny invisible harpoons, and the only thing more contagious than the vibe is the sting. Human encounters, fear, facts, and first aid. Let's be honest, the Portuguese man-o'-war is best admired from a distance, maybe from the safety of a YouTube screen. But if you ever find yourself in the water and ouch, you've been stung, here's what you need to know. The sting. The nematocysts deliver a potent mix of neurotoxins that cause intense pain, redness, and swelling. Most people describe it like 100 tiny fire ants all biting at once. In rare cases, particularly for people with allergies or who receive a massive number of stings, the reaction can be more severe, leading to anaphylaxis or even death. But let's keep perspective. The odds of a fatal encounter are low compared to the number of beachgoers who get a minor sting each year. First Aid 101. 1. Rinse the area with vinegar. Yes, the kitchen staple. Vinegar helps neutralize the nematocysts that haven't fired yet, preventing further toxin release. 2. Remove tentacles carefully. Use a gloved hand or a pair of tweezers. Don't rub the area, or you'll just spread the venom. 3. Soak the sting in hot seawater, around 45 degrees Celsius, that's 113 degrees Fahrenheit, for 20 to 30 minutes. The heat denatures the proteins in the venom, dulling the pain. Tip: if you're on a beach and don't have a thermometer, just grab a bucket of seawater, heat it up on a stove if you can, or use a heat pack if you're lucky. Ice or fresh water can actually make things worse. They can cause the nematocysts to spontaneously fire. Myth busting. They'll kill you instantly. Not true. While a sting is painful, fatalities are extremely rare. They're just big jellyfish. Wrong. As we said, they're colonial hydrozoans, not true jellyfish. Safety tip: if you see a blue-purple, balloon-like float near the shore, stay out of the water. Many beaches post warning flags when a Portuguese man-o'-war bloom is reported. Respect the warning. It's not a suggestion, it's a sting on the radar. In short, if you're on a beach and you see what looks like a floating party balloon, don't bring a party. Bring a pair of long pants and a vinegar-soaked towel. Ecological role and cultural tidbits. Believe it or not, the Portuguese man-o'-war isn't just a pain in the ocean. It plays a key role in marine ecosystems. Prey. They're a tasty snack for sea turtles, especially the loggerhead and hawksbill, some species of fish, like the ocean sunfish, and even certain nudibranchs that have evolved a resistance to their venom. Habitat. The colonies often host commensal organisms, tiny crabs, shrimp, and even some fish that live among the tentacles, grabbing leftovers without getting stung. It's like a tiny floating apartment complex with a built-in security system that only lets the right tenants in. Nutrient cycling. When they die and break down, they release nutrients back into the water, fueling phytoplankton growth, a crucial piece of the ocean's nutrient recycling plant. Cultural references. The name Portuguese man-o'-war has shown up in literature, from Jules Verne's 20,000 Leagues Under the Sea to modern movies. It's often used as a symbol of danger lurking beneath beauty. In Hawaiian folklore, they're known as kaka, and sometimes considered omens of change in the sea. If you ever write a sea monster novel, you could do worse than having a Portuguese man-o'-war as the villain. It's basically a floating antagonist with a built-in sting scene. Summing it all up, let's bring it all together, shall we? A Portuguese man-o'-war is a colonial hydrozoan, a cluster of specialized zooids that floats on a gas-filled sail, trails lethal tentacles, and drifts with the wind across warm seas worldwide. Its venom can deliver a painful sting, but fatal encounters are rare. A shoal of Portuguese man-o'-war is simply a large aggregation of these colonies, often blown together by winds and currents. While the term shoal is technically reserved for fish, the ocean storytellers, including fishermen and beachgoers, have adopted it to describe these spectacular shimmering clusters that can stretch for miles. In short, when you hear shoal of Portuguese man-o'-war, picture a wind-driven fleet of balloon-like invaders, each equipped with a tiny invisible army of stinging darts. They're beautiful from afar, deadly up close, and a perfect reminder that the ocean's wonders are often a mix of awe and ouch. Thanks for joining me on this sting-filled expedition. If you enjoyed the ride, maybe you learned something, maybe you laughed at a jellyfish joke, let me know in the comments below. What other marine mysteries should we tackle next? And if you're feeling generous, give this video a thumbs up, share it with your friends who think a Portuguese man-o'-war is a type of warship, and subscribe if you haven't already. Remember, the ocean is full of surprises. Sometimes they look like a balloon, sometimes they look like a myth, and sometimes they're just a shoal of floating painmakers. Until next time, stay curious, stay safe, and keep asking, what is? Imagine you're hiking through a Southeast Asian rainforest. The humidity is oppressive. You've got about 15 pounds of gear on your back, and you've been mosquito bait for the last 2 hours. You've made the classic mistake of wearing cotton in the tropics. Don't do that, by the way. And you're starting to think this nature thing was overrated. Then you hear a rustle in the leaves above. You look up, and there, slithering through the canopy, gliding from tree to tree with the grace of a flying squirrel and the terrifying elegance of something that absolutely should not be airborne, is a snake, a flying snake. Your brain, reasonably, does a small internal meltdown. Because here's the thing, snakes don't fly. Everyone knows that. Snakes are legless, slithering, ground-dwelling creatures that belong on the earth or in the water or inside of your worst nightmares. They don't fly. That's not a thing. Except, spoiler alert, it absolutely is a thing. And today, we're going to answer the question that has probably never crossed your mind until right this second. What is a flying snake? Stay with me. Because these creatures are genuinely one of the most bizarre, least understood, and honestly kinda adorable things slithering around this planet. Welcome back to What Is, the channel where we answer questions you didn't know you needed answered, dive into topics you probably never thought about, and occasionally make you reconsider your entire understanding of the natural world. Today we're doing something a little different. We're not talking about a concept or a place or an event. We're talking about an animal, specifically one of the most improbable animals on Earth, the flying snake. By the end of this video, you're going to know more about these gravity-defying serpents than 99.9% of the human population. And you'll probably also be a little unsettled. That's fair. Snakes do that to people. But stick around, because these little guys are genuinely fascinating. And I'm not just saying that because I have a mild snake obsession. Okay, I am saying that, but still, flying snakes, come on. The basics. What exactly is a flying snake? Let's start with the basics. Flying snake is a common name for 5 species within the genus Chrysopelia. That's Chrysopelia, for all you taxonomy enthusiasts out there. And yes, that's a real genus name. No, I don't know who named it. Probably someone who was very excited about Greek words. These snakes belong to the family Colubridae, which is the same family that includes about 1/3 of all known snake species. So technically, flying snakes are just really fancy colubrids. Fancy, flying colubrids. The 5 recognized species are Chrysopelea ornata, the golden tree snake, also called the ornate flying snake. This is probably the most common one you'll see in photos, and honestly, the prettiest. It's got these gorgeous green and gold patterns that look like someone painted it. Chrysopelea paradisi, the paradise tree snake. This one lives up to its name, with stunning green, black, and yellow markings. It's like a piece of jewelry that happens to be a cold-blooded reptile. Chrysopelea peluensis, the Palau flying snake. Found only in the Palau Islands, this one's a bit of a regional celebrity. Chrysopelea rhodopluron, the Indian flying snake. Found in, wait for it, India. Revolutionary naming there. And finally, Chrysopelea taprabanica, the Sri Lankan flying snake. Found in, you guessed it, Sri Lanka. Someone was really phoning it in on the creative naming department. But here's what's important. All 5 species share one incredible ability. They can glide through the air. Not exactly fly in the way a bird or a bat flies. They're not generating lift with wings or propelling themselves with muscles. But they can launch from trees and glide considerable distances, which is honestly more than enough to freak out anyone who encounters one. So now that we know what they are, let's talk about the elephant, or rather the snake, in the room. How in the absolute heck do they do that? The mechanics. How do they fly? Okay, so here's where it gets really interesting. Flying snakes are what's called arboreal, which means they live in trees. And like most arboreal snakes, they're excellent climbers. They use their muscular bodies to grip branches and scale trunks with surprising agility. But about 15 million years ago, or possibly earlier, the timeline is a bit fuzzy. Something cool happened. These tree-dwelling snakes started developing a unique ability. They could flatten their bodies. And I don't mean flatten like when you accidentally sit on a garden hose. I mean flatten. When a flying snake prepares to take a glide, it tenses its muscles and actually widens its ribcage, compressing its normally round body into a sort of concave shape, like a warped frisbee. It then positions itself at the edge of a branch, coils up, and launches. And here's the wild part. It doesn't just fall. It's not a controlled fall, like a skydiver. The flattened body actually creates aerodynamic lift. The snake undulates through the air, moving in a wave pattern much like it does when slithering on the ground. And this movement helps stabilize its glide. It can adjust its trajectory mid-air by making small movements with its body, which is honestly kind of impressive for a creature with 0 limbs. The whole glide typically lasts only a few seconds, but during that time, the snake can travel up to 100 meters, over 300 feet, while losing surprisingly little altitude. Some researchers have recorded glides of nearly 25 meters vertically, which for a snake is basically a skywriting accomplishment. Now I'm going to be honest with you. Scientists have been studying this phenomenon for decades, and they're still not 100% sure exactly how the aerodynamics work. The leading theory is that the snake's flattened body acts like a parachute combined with a glider, creating a larger surface area that catches air and slows the descent, while also generating some forward momentum. But honestly, the more I read about it, the more it seems like these snakes are just doing something that shouldn't work and getting away with it. Like they looked at the laws of physics, shrugged, and said, "Hey, close enough." And honestly, I respect that energy. Habitat and distribution. So where can you find these little glide monsters? Flying snakes are native to South and Southeast Asia. Specifically, you can find them in parts of India, Sri Lanka, Bangladesh, Myanmar, Thailand, Laos, Cambodia, Vietnam, Malaysia, Indonesia, and the Philippines. They're most commonly found in tropical rainforests, but some species have adapted to agricultural areas and even urban environments. The paradise tree snake, Chrysopelia paradisi is probably the most widespread and studied of the bunch. It lives throughout its range in lowland forests and is particularly comfortable near human settlements. If you're in Thailand or the Philippines and you see a snake gliding between buildings, it's probably this one. Not that that thought is comforting. But hey, it's usually not aggressive, so there's that. The golden tree snake, Chrysopelia ornata, is found across a huge range, from India all the way to China. It's a bit more secretive than its cousins, preferring dense forest canopy where it can hunt in peace. And then there's the Palau flying snake, Chrysopelia paluensis, which, as the name suggests, is only found in Palau. That's a small island nation in the western Pacific Ocean. This snake is so specialized to its island home that it's considered vulnerable to extinction, but more on that later. What's important to note is that these snakes are arboreal. They almost never go to the ground unless they're forced to. They eat, sleep, mate, and travel almost exclusively in the canopy, which is one of the reasons most people never see them. That, and they're relatively small. Most species max out at around 3 to 4 feet long, with the golden tree snake sometimes reaching 5 feet, which is still not enormous by snake standards. So if you're out hiking in Southeast Asia, and you look up and see something gliding between trees, now you know what you're looking at, and you can tell your friends you saw a real live dragon. Close enough. Behavior and diet. Now let's talk about what these snakes actually do all day. Because it's not just gliding, you know, they've got a whole lifestyle. Flying snakes are diurnal, which means they're active during the day. This is unusual for many snake species, which tend to be nocturnal or crepuscular, active at dawn and dusk. But these snakes? They're out here living their best lives while the sun's up. They're also constrictors, which means they kill their prey by wrapping around it and squeezing until the prey suffocates. I know suffocate sounds a bit gentle. Let's just say they cut off blood flow to vital organs, which is scientifically accurate and sounds slightly less gentle. Either way, it's effective. Their diet consists mainly of small vertebrates, birds, lizards, frogs, and sometimes small mammals. They're not venomous to humans, so if one were to bite you, which is unlikely since they're quite docile, it would be like a bee sting. Unpleasant, but not dangerous. Wait, let me make sure I didn't just say not venomous, because I need to be clear here. Flying snakes are completely harmless to humans. They have no venom. They have no fangs worth mentioning. They're not constrictors that can wrap around a human arm and squeeze. Well, they could try, but they're too small to do any real damage. Honestly, if a flying snake tried to hurt you, your worst injury would be a minor scratch and a bruised ego. This is important because a lot of people see a snake, any snake, and assume it's dangerous. But flying snakes are basically the puppy dogs of the snake world. Curious, gentle, and mostly interested in hunting small prey rather than terrifying humans. Of course, that doesn't stop people from being terrified of them. Fear of snakes is one of the most common phobias on the planet. Some studies suggest up to a third of all humans have ophidiophobia, which is the clinical term for fear of snakes. And honestly, seeing a snake gliding towards you at eye level probably doesn't help. But here's the thing, these snakes want absolutely nothing to do with you. They're not aggressive. They're not going to chase you. They're not even going to hang around if you're making noise. They are spectacularly uninterested in human interaction, which is honestly more than I can say for some humans. Myths and misconceptions. Alright, let's address some of the nonsense that gets spread about these creatures, because there's actually a decent amount of misinformation out there. First, let's get this out of the way. No, flying snakes cannot actually fly. They glide. I know I keep emphasizing this, but it's important. They're not levitating. They're not sprouting wings. They're not mini serpents of the sky. They're doing a very specialized form of controlled falling, which is honestly impressive enough without pretending they're magic. Second, no, they're not poisonous. I've seen some truly wild claims on the internet about flying snakes being among the most venomous creatures in Asia, which is just not true. These snakes are completely harmless. I cannot stress this enough. If you see one in the wild, You don't need to do anything except appreciate it from a safe distance and maybe take a cool photo. Third, and this one's a bit more nuanced, they're not trying to fly to get away from predators, or to hunt, or to show off. The current scientific consensus is that gliding is probably an energy-efficient way to move between trees in the canopy. Instead of crawling all the way down one tree, crossing the ground where they'd be vulnerable to predators, and then climbing back up another tree, they can just glide. It's the snake equivalent of taking a shortcut, except the shortcut involves becoming briefly airborne. Some researchers also think that juvenile flying snakes might glide more than adults, possibly because they're smaller and lighter and can glide further. But honestly, there's still a lot we don't know about these creatures. Research is ongoing, and new discoveries are being made all the time. Alright, we're about halfway through this video, and I wanted to take a quick break to say something important. If you're enjoying this deep dive into the wonderful world of flying snakes, don't forget to like this video and subscribe to What Is, if you haven't already. We put a lot of research into these videos, and it helps us out enormously when you engage with the content. Also, if you have questions about flying snakes or any other topics you'd like us to cover, drop them in the comments below. We've got a lot of ideas for future videos, but we're always happy to hear what you want to learn about. Alright, back to the snakes. Conservation status. Now I want to talk about something a little less fun, but still important. Conservation. Most flying snake species are currently listed as least concern by the IUCN, the International Union for Conservation of Nature, which means they're not immediately threatened with extinction. This is good news generally, but it's not a reason to be complacent. The biggest threats to flying snakes are habitat loss and fragmentation. As Southeast Asia experiences more deforestation for agriculture, logging, and urban development, these arboreal snakes lose the canopy habitat they need to survive. They're not adapted to living on the ground, so when their forest homes disappear, they have nowhere to go. The Palau flying snake, Chrysopelia pilawensis, is in a slightly more precarious position. It's found only on a few islands in Palau, and its habitat is limited. It's currently listed as vulnerable, which means it's at higher risk than its cousins. If you're ever in Palau and you see one of these snakes, you're looking at something that's pretty special and potentially endangered. Beyond habitat loss, there's also the pet trade to consider. Flying snakes are occasionally captured for the exotic pet industry, although they're not as popular as some other species. This is less of a concern than habitat destruction, but it's still something to be aware of. The good news is that flying snakes are relatively adaptable, at least compared to some other species. They've been known to live in agricultural areas, and even in cities, as long as there's enough tree cover for them to navigate. They're survivors. They've been doing this gliding thing for millions of years, and they're not going anywhere just because humans are around. But it's still worth being mindful of our impact on their habitats. Because let's be honest, we need the snakes more than they need us. They've been doing just fine for millennia without us. We can't say the same. Cultural significance. Now let's talk about how humans have perceived these creatures throughout history, because it's actually pretty interesting. In many parts of Southeast Asia, flying snakes have a place in local folklore and mythology. In some cultures, they're seen as symbols of good luck or spiritual protection. In others, they're associated with rain and fertility, probably because they often appear during the monsoon season, when the canopy is lush and full of prey. The golden tree snake, Chrysopelia ornata, is particularly significant in some regions. In parts of India and Sri Lanka, it's sometimes considered sacred, associated with the Hindu deity Vishnu. In fact, one of the species' common names in Sri Lanka is Udusapa, which translates roughly to flying snake in Sinhala. It's not a phrase you're going to use in everyday conversation, but it's neat to know. Now, I'm not going to pretend that all cultural attitudes toward flying snakes are positive. In many places, any snake, even a completely harmless, gently gliding one, is seen as something to be feared or killed. This is understandable from an evolutionary perspective. Our ancestors who were wary of snakes were more likely to survive and pass on their genes. But it does mean that flying snakes sometimes face persecution from humans who see them as threats, even when they're not. There's also the occasional media sensationalism. Every few years, some outlet will run a story about the deadly flying snake, or the snake that can kill you from the sky, and it's almost always exaggerated or completely false. These stories do a disservice to both the snakes and the public, who end up unnecessarily afraid of creatures that are genuinely fascinating and harmless. Why this matters. The bigger picture. Here's why any of this matters. Flying snakes are a reminder that nature is full of surprises. They're a living example of evolution doing its thing, adapting creatures to their environments in ways that seem almost impossible until you see them in action. They challenge our assumptions about what animals can and can't do. They're a small window into the incredible diversity of life on this planet and the endless creativity of evolution. And honestly, they're just cool. There's nothing wrong with appreciating a creature because it's neat, even if there's no practical reason to care about it. Flying snakes don't need to be useful to be worth protecting. They don't need to benefit humans in any way to deserve a place in the world. They exist, and that's enough. But here's the practical side. Flying snakes also play an important role in their ecosystems. As predators, they help control populations of small animals, like lizards and frogs. They're part of a complex web of relationships that makes healthy ecosystems function. If they disappeared, there would be consequences. Consequences we might not fully understand until it's too late. So whether you're someone who loves animals, or just someone who likes the idea of a world full of weird, unexpected creatures, flying snakes are worth caring about. They're worth learning about, and they're worth protecting. Fun facts, the best bits. Alright, let's end on a high note with some fun facts that might make you the most interesting person at your next dinner party. Fact 1. Flying snakes can glide up to 100 meters. That's over 300 feet in a single glide. That's longer than a football field. Imagine if you could just launch yourself that far. You'd never need to learn to drive. Fact 2. They flatten their bodies not just horizontally, but vertically too. Sort of. When they're preparing to glide, their ribs spread apart, and their bodies become almost ribbon-like. It's like they turn themselves into tiny, scaly paragliders. Fact 3. Baby flying snakes can actually glide better than adults, at least in proportion to their size. This might be because they're lighter, or it might be because they practice more. Yes, baby snakes practicing to fly. I know. Fact 4. They've been observed gliding in rainy weather, which is impressive when you consider that rain adds weight and makes gliding harder. These snakes are apparently not great at checking the weather forecast before heading out. Fact 5. They're not related to any other gliding animals. Flying squirrels, flying lemurs, and Draco lizards, all completely different lineages. Flying snakes evolved their gliding ability independently, which is pretty rare in the animal kingdom. Fact 6, and this is my favorite. There's a video going around of a flying snake gliding in slow motion, and it's legitimately one of the most surreal things you'll ever see. It looks like a snake-shaped piece of ribbon floating through the air. It's equal parts beautiful and completely wrong. I highly recommend looking it up if you want to lose 10 minutes of your day to the internet. So there you have it. Flying snakes, arboreal, constricting, gliding serpents that somehow make the impossible look easy. They're a testament to the weirdness and wonder of the natural world, and a reminder that there's always something new to discover. Next time you're in a Southeast Asian rainforest, or even just watching a nature documentary, keep an eye out for these incredible creatures. They're out there, doing their thing, gliding between trees like they forgot gravity was supposed to be a thing. And if you do see one, don't panic, don't run. Just watch, appreciate, and maybe take a mental note to tell your friends about the time you saw a snake flying. Because not many people can say that. And that's it for today, folks. If you learned something new, and I hope you did, make sure to like this video and share it with your friends. The more people who know about these incredible creatures, the better. Also subscribe to What Is if you haven't already. We've got lots more videos like this one, covering all sorts of topics you probably never thought to ask about. There's a whole library of weird, wonderful, and occasionally terrifying knowledge waiting for you. And don't forget to check out our other videos. I've got links right here on screen. There's everything from deep dives into historical events, to explanations of natural phenomena, to breakdowns of concepts you've probably heard about, but never fully understood. Thanks for watching, everybody. I'll see you in the next one. Welcome to What Is, the show where we dive deep into the corners of the natural world to find things that probably shouldn't exist, yet somehow very much do. Today we're looking at an animal that looks like a gummy candy, hunts like a tactical SWAT team, and has been reusing the same biological blueprint since before the dinosaurs were even a twinkle in a reptile's eye. I'm talking about the Onychophora, or as you can call them, the velvet worm. Now before we get started, if you enjoy learning about the weird, the wild, and the why does this have so many legs, make sure to hit the subscribe button and ring the notification bell. You don't want to miss what we've got coming up next. Alright, let's talk about the velvet worm. Imagine, if you will, a creature that is part caterpillar, part slug, and part high pressure glue gun. It's soft, it's squishy, and it looks like it was knitted by a grandmother who had a very loose understanding of what a bug is supposed to look like. But don't let the velvet part of the name fool you. These aren't the plushies of the forest floor. They are highly efficient, ancient, and surprisingly social predators. First, let's address the name. Why velvet? If you were to touch one, which, honestly, they probably wouldn't appreciate, it wouldn't feel slimy like an earthworm or hard like a beetle. They are covered in millions of tiny, scale-like bumps called pupae. These pupae are waterproof and are what give the worm its matte, velvety sheen. They are basically the nature version of a high-end luxury car wrap. But under that soft exterior is a creature that hasn't changed its basic design in over 500 million years. To put that in perspective, 500 million years ago, North America was still hanging out near the South Pole, and life was mostly just things bumping into each other in the ocean. The velvet worm is what scientists call a living fossil, while everything else was busy evolving wings, or a backbone, or the ability to pay taxes. The velvet worm looked at itself in a Cambrian era puddle and said, yeah, this is fine, I'm good. They belong to their own phylum, Onychophora. This is a big deal in biology. Most of the animals you see fit into huge categories. You got chordates, that's us, dogs, birds, fish. You got arthropods, insects, spiders, crabs. Velvet worms, they're their own thing entirely. They sit right in the middle, like the missing link between soft-bodied worms and hard-shelled insects. They have these stubby, unjointed legs called lobopods. They don't have joints like your knees or an ant's legs. Instead, their legs are basically fleshy balloons filled with fluid. They move by changing the internal pressure of their body, which is called a hydrostatic skeleton. It's the same way a balloon animal would walk if it suddenly gained sentience and a hunger for crickets. And they have a lot of legs. Depending on the species, we're talking anywhere from 13 to 43 pairs. At the end of each little leg, tiny retractable claws. In fact, Onychophora literally means claw bearers. But let's get to the part that everyone actually wants to hear about, the weaponry. If you're a small insect, say a cricket or a woodlouse, the velvet worm is the monster in a horror movie. It stays in the shadows, it's nocturnal, it's slow, very, very slow. It creeps up on you with its sensitive antennae, feeling the vibration in the air. And then it brings out the cannons. Located on either side of its head are two specialized glands called oral papillae. Think of them as high-pressure nozzles. When the velvet worm is within range, it contracts its body and fires. Two streams of milky, translucent slime shoot out at a high velocity. The worm weaves its head back and forth as it fires, zigzagging the spray like a frantic firefighter, coating the prey in a sticky web of biological glue. This isn't just any glue. This stuff is a masterpiece of chemical engineering. When it's inside the worm, it's a liquid. But as soon as it hits the air and the target starts to struggle, the mechanical stress causes the proteins in the slime to harden into stiff, rubbery threads. The more the prey fights, the tighter the trap becomes. It's the ultimate stop hitting yourself move of the animal kingdom. The cricket is essentially shrink wrapped in seconds. And here's the kicker. The velvet worm is a master of recycling. Once the prey is immobilized, the worm crawls over, and because the slime is made of expensive proteins that take a lot of energy to produce, the worm eats the slime back up while it eats its dinner. It's like a hunter who shoots a net at the deer and then eats the net alongside the venison to save on equipment costs. Now, how does it eat something with a hard shell when its own body is as soft as a marshmallow? It uses those claw-bearer traits. It has a pair of sickle-shaped jaws hidden inside its mouth. It bites a tiny hole into the prey's exoskeleton and injects digestive enzymes. Essentially, it turns the inside of the insect into a protein shake. Then it just sucks the liquid out, leaving behind an empty, hollow shell. But wait, it gets weirder. We usually think of invertebrates as solitary, mindless drones. But some species of velvet worms, like those found in Australia, are surprisingly social. They live in groups, they hunt in packs, and they have a strict social hierarchy. There is a dominant female, the queen if you will. When the group finds a large kill, she is the first to eat. The other worms wait until it's their turn based on their rank in the hierarchy. If a lower ranked worm tries to cut the line, the queen will literally push them away. It's high school cafeteria drama, but with more slime cannons. Hunting in groups allows them to take down prey much larger than themselves. It's a level of cooperative behavior that's incredibly rare for something that doesn't have a centralized brain. Speaking of brains, the velvet worm's nervous system is also a bit of a throwback. They have two nerve cords running the length of their body, but they aren't fused like ours. This gives them a very decentralized way of processing the world. They aren't thinking about philosophy, they're thinking about moisture, shadows, and the next thing they can turn into a juice box. Moisture is the key to their entire existence. Because they have very thin skin and breathe through tiny permanent openings called trachea that they can't close, they are at constant risk of drying out. If a velvet worm stays in the sun for too long, it literally evaporates. This is why you'll only find them in dark, damp places, rotting logs, deep leaf litter, or caves. They are the ultimate basement dwellers of the forest. Now let's talk about the birds and the bees, well, worms. Velvet worm reproduction is where things go from weird to how is this real? Some species lay eggs, standard stuff, but others give birth to live young. And I don't mean eggs hatching inside the body. I mean some species have placenta-like connection where the mother provides nutrients to the developing embryos for months or even over a year. When the babies are finally born, they are miniature versions of the adults. They come out fully formed and ready to start shooting slime and ignoring their parents. But the way the sperm gets to the eggs in some species is truly bizarre. In certain species, the male doesn't have a standard way of delivering his genetic material. Instead, he places a packet of sperm, a spermatophore, anywhere on the female's body, just drops it off like a package on the porch. The female's skin then dissolves under the packet, and the sperm cells migrate through her body cavity, swimming through her blood, which is more of a clear liquid called hemolymph, until it reaches her ovaries. It's an anatomical all-terrain shortcut. So why should we care about this squishy, glue-spitting ancient worm? Because the velvet worm is a survivor. It has survived 5 mass extinction events. It saw the Permian extinction wipe out 90% of life on Earth and just kept on vibing in its rotting logs. It saw the asteroid hit the Yucatan Peninsula and thought, I hope it's raining, I'm feeling a bit dry. They are a window into a world that existed before bones, before flowers, and before trees. They represent a branch of life that found a perfect niche and stayed there. But even these ancient survivors are in trouble. Because they are so specialized for damp, stable environments, they are incredibly sensitive to habitat loss and climate change. If a forest is cleared, the microclimate changes, the humidity drops, and the velvet worms disappear. Many species are found only in tiny specific pockets of the world. Some species are known only from a single hillside or a specific cave system. This makes them incredibly vulnerable. When we lose a species of velvet worm, we're not just losing a bug, we're losing 500 million years of uninterrupted evolutionary history. So next time you're walking through a rainforest or flipping over a damp log, keep an eye out for a little piece of the Cambrian period. It might look like a discarded gummy worm, but it's actually one of the most sophisticated ancient hunters on the planet. Just maybe don't get too close. You don't want to find out how hard it is to get that slime out of your clothes. Believe me, it's a nightmare. That's all for today's look into the what is of the velvet worm. If you learned something new, or if you now have a localized fear of being turned into an insect protein shake, give this video a thumbs up. What should we cover next? Are there other living fossils that you're curious about? Or maybe a creature that's just as strange but doesn't have quite as many legs? Let us know in the comments below. We read every single one, mostly because we're looking for more excuses to research weird animals. Don't forget to subscribe to What Is for your daily dose of the world's most fascinating facts. Thanks for watching, and we'll see you in the next one. Stay curious. Welcome back to What Is, the channel where we dive deep into the fascinating, the complex, and sometimes the utterly bizarre corners of our world. Today, we're not talking about black holes, or ancient civilizations, or quantum physics. Not directly, anyway. Today, we're zooming in, way in, on something so tiny, so unassuming, you've probably never even noticed it. And yet, this microscopic marvel possesses superpowers that would make any comic book hero green with envy. Forget Superman. Forget the Hulk. Today we're talking about the toughest creature on Earth, possibly in the entire known universe. We're talking about the water bear, the moss piglet, the unsung hero of microscopic resilience. We're talking about the tardigrade. What are they? The basics. So, what is a tardigrade? Well, let's start with the basics. A tardigrade is a microanimal, part of a phylum all of its own called Tardigradia. They are invertebrates, meaning they don't have a backbone, and they are more closely related to arthropods, like insects and crustaceans, and nemomods, those microscopic worms, than they are to us. The name tardigrade itself comes from the Latin meaning slow stepper, and when you see them under a microscope, lumbering along with their 8 stubby legs, you'll understand why. They look like a tiny, roly-poly bear, hence the charming nickname, water bear, or, if you prefer, moss piglet, because they often live in moss. Adorable, right? Right up there until you realize how utterly indestructible they are. These little guys are truly microscopic. Most tardigrades are less than a millimeter long, typically between 0.3 and 0.5 millimeters. That's about the size of a grain of sand. You could fit several hundred of them on the head of a pin, which, frankly, is possibly for the best, because if they were any bigger, they'd probably already be in charge. They have segmented bodies, 8 legs, each ending in 4 to 8 claws, Think of a tiny, plump, 8-legged caterpillar wearing boxing gloves, and they have a mouth part that protrudes, armed with stylets, which are tiny, sharp spears they use to pierce plant cells, algae, or even the bodies of other tiny creatures to suck out their delicious, nutritious insides. Yes, some tardigrades are tiny, adorable, cannibalistic vampires. The more you know. And where do they live? Well, everywhere. Literally. Tardigrades are cosmopolitan, which is a fancy way of saying they can be found from the highest mountains to the deepest seas, from the polar ice caps to scorching deserts, from rainforests to your backyard pond. If there's a patch of moss or lichen, if there's a damp leaf litter, a bit of soil, or even just a persistent puddle, chances are there are tardigrades there, just chilling, doing their slow-stepping thing. They are truly the unsung, omnipresent heroes of the microscopic world. A day in the life of a water bear. So what does a typical day look like for a creature that small, that slow, and that ubiquitous? Most of the time, it's pretty low-key. They spend their days crawling around looking for food, mainly algae, lichens, and moss, using those little stylets to slurp up the cell contents. Some species are predators, though, as we mentioned, preying on rotifertors, nematodes, and even other smaller tardigrades. It's a tough world out there in the microverse. Their movement is deliberate. They extend their 4 front pairs of legs, grip the surface with their claws, and then drag their bodies forward. It's not exactly a sprint, but then, when you can survive pretty much anything, what's the rush? Reproduction for tardigrades can be a bit varied. Some species reproduce sexually, with males and females coupling for up to a microscopic equivalent of a romantic evening. Others are parthenogenic, which means females can lay unfertilized eggs that develop into new tardigrades. It's basically cloning themselves. A neat trick if you're living in a harsh environment and don't have time for dating. Speaking of harsh environments, this is where our story gets really interesting. Because while their day-to-day might be mundane, their ability to survive the not-so-mundane is absolutely legendary. The superpowers begin. Cryptobiosis. Alright, buckle up, because this is where the tardigrade goes from cute little moss piglet to the indestructible real-life superhero. Their most famous superpower is something called cryptobiosis. Don't worry, it's not a secret society of cryptozoologists. Cryptobiosis is a reversible, metabolic state of suspended animation. Think of it like pressing the pause button on life itself. When conditions become unfavorable, say too dry, too cold, too hot, or even not enough oxygen, tardigrades can essentially shut down almost all their life processes. The most well-known form of cryptobiosis is anhydrobiosis, which literally means life without water. This is their party trick. When the environment dries out, instead of shriveling up and dying like pretty much every other living thing on the planet, tardigrades retract their heads and legs, curl up into a compact, barrel-shaped form called a tun, T-U-N. In this tun state, their metabolism can drop to less than 0.01% of its normal rate. They lose almost all their body water, sometimes down to just 3%. They become essentially a desiccated husk. And they can stay like that for decades. Imagine a tiny dried up barrel sitting there waiting. Then introduce a drop of water and within minutes, or sometimes hours, they rehydrate, unfurl, and go right back to lumbering around and eating algae as if nothing has happened. They literally come back to life. It's not just surviving, it's actively waiting out the apocalypse. How do they do this? A couple of incredible tricks. One is a special sugar called trehalose. This sugar forms a glassy matrix inside the cells, protecting their delicate cellular structures and molecules, like proteins and DNA, from damage during desiccation. Think of it like a biological shrink wrap. Another key player is a group of specialized proteins called Lie proteins, LEA, or late embryogenesis abundant proteins, which also help prevent damage to cell components during drying. They are like microscopic bodyguards for your inner workings. But anhydrobiosis is just one flavor of their cryptobiotic deliciousness. They also exhibit cryobiosis. This is survival in extreme cold. They can freeze solid, be thawed out, and walk away perfectly fine. We're talking about temperatures down to near absolute zero, minus 272 degrees Celsius. That's colder than the deepest reaches of space. Osmobiosis. This allows them to survive in extremely high concentrations of salt or other solutes, environments that would instantly poison most other organisms. And anoxybiosis, survival without oxygen. When oxygen levels drop too low, they can swell up with water, becoming turgid and immobile, effectively entering a state of suspended animation until oxygen returns. So when the zombie apocalypse comes, and the world is ravaged by destruction, extreme cold, toxic oceans, and lack of breathable air, don't worry about the cockroaches, worry about the tardigrades. They'll be fine. In fact, they'll probably just be having a tiny, slow-motion party. Extreme survival. What can they endure? Now, let's get into the specifics of just how much abuse these little guys can take, because it's truly mind-boggling. Temperature. We briefly mentioned it, but let's reiterate. They can handle temperatures as low as minus 272 degrees Celsius. That's just 1 degree above absolute zero, and as high as 150 degrees Celsius, well above boiling point. Imagine enduring temperatures ranging from the surface of Pluto to the inside of a hot oven. Humans, we get a bit whiny if the air conditioning isn't just right. Radiation. This is where it gets truly sci-fi. Tardigrades can withstand doses of radiation hundreds, even thousands of times higher than what it would take to kill a human. A human would die from about 5 to 10 grays of radiation. Some tardigrade species can survive over 5,000 grays. That's enough to sterilize a hospital. Researchers identified a unique protein in some tardigrades, aptly named DSUP, for DNA damage suppressor, that literally shields their DNA from radiation-inducing damage. They have a biological force field for their genes. The vacuum of space. Yes, you heard that right. In 2007, the European Space Agency sent a group of tardigrades into low Earth orbit on the Photon M3 mission. For 10 days, these tiny adventurers were exposed to the full, unfiltered vacuum of space, including dangerous levels of solar UV radiation and cosmic rays. When they returned, many of them not only survived, but were able to reproduce. They are literally the first known animals to survive direct exposure to the vacuum and radiation of outer space. Take that, Captain Kirk. Pressure. Think of the deepest part of the ocean, the Mariana Trench, where the pressure is immense, over 1,000 times atmospheric pressure. Tardigrades can survive pressure up to 6 times that. Imagine a tiny creature designed to withstand the crushing weight of an entire planet. Toxic chemicals. While not immortal, they show remarkable resilience to many toxins and pollutants that would be fatal to most other forms of life. So when you consider all of this, it's clear tardigrades are not just tough, they're essentially indestructible on an earthly scale. They've evolved survival mechanisms that push the very boundaries of what we thought life could endure. Why do we care? Beyond the sheer fascination of these microscopic marvels, why do tardigrades matter to us? Well, their extreme resilience has profound implications across various fields. Scientists are intensely studying their cryptobiotic mechanisms, the trehalose sugar, the Li proteins, the DSUP protein, hoping to unlock secrets that could revolutionize medicine. Imagine being able to cryptopreserve organs for transplant for extended periods,
or developing drought-resistant crops by introducing tardigrade-like survival genes? What if we could give astronauts better radiation protection for deep space missions, or even stabilize vaccines and medicines so they don't require refrigeration, making them accessible in remote, underserved areas? The potential applications are truly astounding. Tardigrades remind us that life, in its most fundamental forms, is incredibly tenacious. It finds a way, even in the most hostile conditions imaginable. They are a testament to evolution's ingenuity, providing a living example of how organisms adapt to survive the absolute worst that the universe can throw at them. They are tiny, humble ambassadors of resilience, reminding us that even the smallest among us can possess the greatest strengths. From their adorable lumbering walk to their astonishing ability to cheat death itself, tardigrades have certainly earned their place as one of the most incredible creatures on our planet. They prove that you don't need to be big or flashy to be a true survivor. Sometimes the most powerful things come from the tiniest packages. So the next time you look at a patch of moss or a droplet of water, remember the water bear, the moss piglet, the slow-stepping superhero that might just be peering back at you, waiting for its next adventure. What other unsung heroes of the natural world should we explore? Let us know in the comments below. If you found this journey into the microscopic world fascinating, please hit that like button, share this video with your friends, and don't forget to subscribe to What Is for more deep dives into the mysteries and wonders of our universe. Hit that notification bell so you don't miss our next episode. Thanks for watching, and we'll see you next time.
Welcome back to What Is, where we take the things you see every day and realize you actually know absolutely nothing about them. Today, we're looking at an animal that is essentially a high fashion model that started its life as a very hungry, very tubular sock. We're talking about the butterfly. But what actually is a butterfly? Is it a bird? No. Is it a moth with a better publicist? Maybe. In this video, we're going to peel back the wings on these lepidopterans to discuss their weird names, their body liquefying growth spurts, their global real estate, and why everyone keeps blaming them for hurricanes in Brazil. First, let's talk about the name, etymology. If you look at the word butterfly, it doesn't make a lot of sense. It's butter and fly. To my knowledge, no butterfly has ever produced dairy, nor do they taste like butter. Please do not test this. The Old English word was butterfleog. Why? Historians are actually divided, which is an academic way of saying we're guessing. One popular theory is the name came from the yellow brimstone butterfly, which is, well, butter-colored. Another slightly more chaotic theory from German folklore suggests that people believed butterflies were actually witches in disguise, who flew around stealing butter and cream from farmhouses. Imagine being a 14th century farmer, seeing a tiny insect and screaming, "There goes the margarine thief! Fetch the pitchfork." Anyway, the name stuck. In other languages it's much more poetic. In French it's papillon, in Spanish it's mariposa, in Dutch it's vlinder. But in English we decided churn fat insect was the way to go. Now let's move from the name to the creature itself. What is a butterfly biologically? They belong to the order Lepidoptera. That comes from the Greek lepis meaning scale and pteron meaning wing. If you've ever touched a butterfly's wing, which you shouldn't, they're fragile, and gotten that weird dust on your fingers, those are tiny microscopic scales. They're like shingles on a roof. These scales give them colors through pigments, or through structural trickery where light bounces off the scales to create iridescence. They are literal masters of optical illusions. But a butterfly doesn't just poof into existence looking like a stained glass window. It has to earn it through the most metal biological process on Earth, the life cycle. Stage 1, the egg. A mother butterfly is very picky. She doesn't just drop an egg anywhere. She glues it to a specific plant that her future children will actually eat. It's like a prenatal meal plan. Stage 2, the larva, or as we call it, the caterpillar. The job of a caterpillar is simple. Eat. Just eat. A caterpillar will often increase its body mass by several thousand times in just a few weeks. If a human baby grew at that rate, a 2-week-old infant would weigh as much as an elephant. They are essentially a digestive tract with legs. They have 12 eyes, but they can barely see. They don't care about the view, they care about the buffet. Stage 3, the pupa. This is where things get weird. The caterpillar builds a chrysalis. Now, popular media portrays this as a cozy sleeping bag, where the caterpillar grows some wings and wakes up. That is a lie. Inside that chrysalis, the caterpillar releases enzymes that would literally dissolve its own body. It turns itself into a literal protein soup. It's a biological slurry. However, certain imaginal discs, which are little clusters of cells that have been hiding inside the caterpillar since it was an egg, survive this acid bath. These discs use the soup as fuel to build the legs, wings, and eyes of the butterfly. It's the ultimate glow up. You go from a tube that crawls on its stomach to a liquid, to a creature that can fly across oceans. If you think your teenage years were awkward, imagine being a puddle of yourself for 2 weeks. Stage 4, the adult, or the imago. When the butterfly emerges, its wings are soft and wet. It has to pump fluid from its abdomen into the wing veins to inflate them. If it doesn't do this quickly, it will never fly, and its life will be very short and very confusing. As adults, butterflies don't eat, they drink. They have a proboscis, which is basically a long, coiled up straw. They use it to sip nectar, but they also engage in something called mud puddling. If you see a group of butterflies hanging out by a muddy puddle, they aren't having a meeting. They're drinking mineral-rich water, often flavored with animal waste or decaying matter. Yes, the beautiful, majestic butterfly is drinking pea water for the sodium. Nature is disgusting, and we love it. So where do these beautiful pea drinkers live? The answer is everywhere, almost. Butterflies are found on every continent except Antarctica, because obviously butterflies have better things to do than freeze their wings off. They thrive in tropical rainforests, where the diversity is staggering. But you can find them in deserts, on top of mountains, and in your grandmother's flower garden. Some of them are homebodies, never traveling more than a few hundred feet from where they were born. Others are the ultimate long-distance backpackers. Take the monarch butterfly. These orange and black icons engage in multi-generational migration that defies logic. They fly from southern Canada and northern US, all the way to central Mexico. That's a 3,000-mile trip. Here's the crazy part. The butterfly that starts the trip isn't the one that finishes it. It takes 3 to 4 generations to complete the cycle. But the Methuselah generation, the ones that fly to Mexico to hibernate, live 8 times longer than their parents just to survive the winter. And then, somehow, their great-grandchildren find the exact same tree in Canada the next year. They don't have GPS. They use the sun's position and the Earth's magnetic field. Meanwhile, I can't find my car in a grocery store parking lot if I don't use the beep beep button. This brings us to the global status of the butterfly. How are they doing? In short, it's complicated, and not in a good way. Butterflies are what scientists call indicator species, because they are so sensitive to the changes in temperature, light, and chemical balance. Their health tells us the health of the entire ecosystem. If the butterflies are disappearing, the rest of us are probably next. Right now, butterflies are facing the big 3 of extinction: habitat loss, pesticides, and climate change. As we turn meadows into parking lots, and replace wildflowers with manicured lawns, we are essentially destroying their grocery stores. Pesticides intended for pests don't discriminate. They take out the pollinators too. And climate change is shifting the seasons. If a butterfly hatches 2 weeks early because of a warm spell, but the flowers they need haven't bloomed yet, the butterfly starves. The western monarch population, for example, has seen a decline of over 99% since the 1980s. That's not a dip, that's a freefall. But why should we care, besides them being pretty? Butterflies are vital pollinators. While bees get all the credit, and the honey, butterflies are the auxiliary force. They travel longer distances than bees, meaning they spread more genetic diversity among plants across wider areas. Without them, thousands of plant species and the animals that eat those plants would vanish. This leads us to a concept we covered in our video, what is the butterfly effect and is it real? If you haven't seen that one, go check it out after this, linked above. The term was originally coined by Edward Lorenz, a meteorologist. He suggested that the flap of a butterfly's wings in Brazil could set off a chain of atmospheric events that eventually causes a tornado in Texas. Now in pop culture, we use this to mean that if you go back in time and step on a bug, everyone in the future speaks a different language and has 3 heads. But in science, it's about sensitive dependence on initial conditions. It means that small, seemingly insignificant actions in a complex system can have massive, unpredictable results. It's a beautiful metaphor, isn't it? The butterfly is the symbol of the fragile balance of our world. A creature so light it can rest on a petal, yet so influential that its presence, or absence, can change the course of the planet. So what is a butterfly? It's a survivor. It's a shapeshifter. It's a dairy thief from German folklore. It's a traveler that crosses continents without a map. It's a liquid brain miracle that reminds us that change is not only possible, but necessary. Next time you see one, don't just think, oh look, a pretty bug. Think about the fact it survived being dissolved in its own juices just to sit on a flower and look at you. Show some respect. If you enjoyed this deep dive into the world of scales and soup, make sure to hit that like button. It helps the algorithm know we're doing something right. Comment below, what's your favorite type of butterfly? Or tell us about a time you tried to raise a caterpillar and it turned into a nightmare. We want to hear those stories. Don't forget to subscribe to What Is and ring the notification bell so you never miss a video. We've got plenty more deep dives coming your way. Until next time, keep asking questions, keep looking at the small stuff, and maybe plant some milkweed. The butterflies would really appreciate it. Thanks for watching, and see you next time. Have you ever been obsessed with something tiny that you dedicated 15 years of your life to studying it? No? Well, meet Jürgen Otto. For the past decade and a half, this German-born biologist has been travelling to the remote grasslands of Australia, crouching down in the dirt and pointing a camera at a creature so small it could balance on a grain of rice. And he did it all for love. Not human love, mind you, spider love. What you're looking at right now is this peacock spider. It's approximately 5mm long. That's about the height of 2 stacked pennies, or the width of your pinky nail. It has 8 legs, 8 eyes. 2 of them are these magnificent globes that seem to stare directly into your soul. And it's absolutely, positively, irrationally adorable. But here's the thing that makes peacock spiders special. The thing that made Jürgen Otto spend half his career hunched over the Australian shrubbery, like a garden gnome with a camera. This tiny creature with the big eyes is about to do something that will change your entire perspective on spiders forever. He's going to dance. Description. Let's start with the basics, because when we say peacock spider, we're not talking about something that looks like a spider dressed up like a peacock. We're talking about a creature that evolved completely independently to mimic the exact visual language of a bird of paradise, except in arachnid form. The scientific name is Martus volans, and volans means flying, which is a little bit misleading because the peacock spiders don't actually fly. They jump. Spectacularly, they can leap up to 40 times their own body length in a single bound. Imagine you can jump the length of a school bus. That's approximately what the peacock spiders are doing whenever they need to get somewhere quickly. But the really remarkable feature, the thing that makes these creatures an internet sensation and the subject of countless viral videos, is their abdomen. When most people think of spiders, they think of those round, bulbous, slightly unsettling bodies that look like someone inflated a black balloon and gave it way too many legs. Peacock spiders said no. Actually, we'd like to do something more decorative. Their abdomen is covered in overlapping scales in hues that would make a stained glass window jealous. We're talking about deep blues that shimmer like gasoline on water, velvety blacks so dark they seem to absorb light, vibrant oranges and reds that bleed into each other like living flames. And scattered across this kaleidoscopic display are intricate patterns, stripes, spots, geometric shapes. Researchers have spent decades trying to understand them. The males, of course, are the show-offs. They have to be. In the peacock spider's world, males are essentially walking nightclubs, and their bodies are the dance floor, the DJ, and the complimentary cocktail all in one. Females, meanwhile, are dressed in muted browns and greys, practical, understated, and thoroughly unimpressed by ostentatious displays. That sound familiar? Each species of peacock spider has its own unique pattern on its abdomen. There are over 100 known species, mostly concentrated in the arid and semi-arid regions of Australia, though some have been found in parts of Tasmania, and even as far afield as China. Scientists discover new species regularly, which means there's a non-zero chance that somewhere in the Australian outback there's a peacock spider with a pattern nobody has seen before, just waiting for its moment to disco. And perhaps the most remarkable of all this visual splendor is that it's contained within a package smaller than your average Lego piece. It makes you wonder what evolution was thinking. What selective pressure pushed these creatures towards such an extreme decoration? What advantage could possibly come from having a butt that looks like Vincent van Gogh painted it? The answer, as always, when dealing with evolution, is sex. But we'll get to that. Now, can you do us a quick favor? If you're enjoying this deep dive into the world of peacock spiders, would you do us a solid and hit that like button? It really helps the channel out, and it tells YouTube that you want to see more content like this. Also, if you haven't subscribed yet, now would be a great time. We're covering all sorts of fascinating creatures, and there's so much more to explore. Stick with us, and we'll keep bringing you the stories behind nature's most incredible organisms. Okay, let's get back to these dancing spiders. Habitat. Peacock spiders call Australia home, but not the Australia you see in the movies. Forget about koala-filled eucalyptus forests and the Great Barrier Reef. These spiders are creatures of margins, inhabitants of the places that tourists drive through on their way to somewhere else. Their preferred habitat is what's called sclerophyll forests, tough leaf vegetation that has adapted to Australia's poor sandy soils and erratic climate. Think low shrubs, wiry grasses, and open woodlands, where the sunlight filters through in dappled patterns. Places like Stirling Ranges in Western Australia, or the inland regions of New South Wales and Queensland. They've been found in habitats ranging from coastal sand dunes to mountain meadows, though they seem to prefer areas with leaf litter and small hiding places where they can construct their silk retreats. One of the most fascinating aspects of peacock spider habitat is their relationship with the landscape's texture. These are creatures that live in a three-dimensional world we rarely notice. To us, a patch of scrubby brush is just background noise. To a peacock spider, it's a city, a hunting ground, and a dating venue all rolled into one. They navigate using visual clues and spatial memory, returning to favorite perching spots day after day. Males establish and defend territories that might be just a few square meters, tiny kingdoms in the undergrowth. Australia's climate presents unique challenges. These regions experience extreme temperature fluctuations, from scorching summer days that would bake lesser creatures, to winter nights that dip near freezing. Peacock spiders have adapted by being remarkably temperature tolerant, active in conditions that would send most tropical spiders into hiding. They have also evolved a lifestyle that revolves around the Australian spring, when everything comes alive after the long dry period. This seasonal strategy makes perfect sense when you consider that peacock spiders, despite their dazzling displays, are also ambush predators. They don't spin webs to catch food, instead they lie in wait, often near flowers or vegetation where insects come to feed, and pounce when something appropriately sized wanders close. Their exceptional vision, those big beautiful eyes we mentioned earlier, evolved not just for spotting potential mates, but for spotting potential meals. It's a dual-purpose system. Look good, eat well, reproduce, repeat. Life cycle. Now we come to the really spectacular part, the life cycle of the peacock spider, which accumulates in one of the most extraordinary mating displays in the entire animal kingdom. Let's start from the beginning. Female peacock spiders lay eggs in silk sacs, usually buried in soil or concealed in leaf litter. A typical clutch contains anywhere from 4 to 15 eggs, though not all will survive to adulthood. The mother guards these eggs with typical dedication you'd expect from an arthropod. She stays with them, protects them from predators and parasites, and maintains the structure until they hatch. When the spiderlings emerge, they're microscopic replicas of their parents, carrying the same basic body plan in a package roughly the size of a grain of sand. They disperse almost immediately, spinning silk threads that catch the breeze and carry them to new territories, in a process called ballooning. This is a common strategy among spiders, but for peacock spiders, it's the only chance that they have to colonize new areas and avoid competing with their siblings. The juveniles grow through a series of molts, shedding their exoskeletons and expanding into new skins, like tiny inflatable dancers. This process takes several months, with spiders passing through multiple instars, growth stages, before reaching sexual maturity. The timing depends heavily on when they were hatched and local conditions, but most peacock spiders reach adulthood in time for their first spring mating season. And then the dance begins. The mating dance. Imagine, if you will, that you are a female peacock spider. You've just emerged from your winter hideout, and the Australian spring is in full swing. The wildflowers are blooming, the insects are buzzing, and you're in the mood for romance, or at least reproduction. A male approaches. He doesn't just walk towards you. Oh no. That would be too simple, too boring, too reminiscent of how most organisms handle courtship. Instead, he begins what can only be described as a synchronized sensory assault. First, he lifts his third pair of legs, the ones with the distinct black and white tips, then begins waving them in a specific pattern. It's not a random movement. Each species has its own signature rhythm, a choreography passed down through generations of male spiders who mastered the movements and attracted the girls. Think of it as spider breakdancing, except instead of breakbeats, the rhythm is hardwired into his nervous system. As his legs dance, he unfolds his abdomen, revealing those spectacular, colorful scales. But he doesn't just display them, he moves them. He tilts his body, shifts his angle, and positions himself so that the light catches the most iridescent patches at just the right moment. Some males will back towards the female with their abdomen raised. Others will dance sideways in a movement that looks eerily like a human trying to avoid awkward eye contact. The colors aren't just pretty, they're signals. Specific wavelengths to communicate specific information to the female. Species identity, male quality, even genetic compatibility. Female peacock spiders can see into the ultraviolet spectrum, which means they're perceiving displays that are completely invisible to us. What looks like a pretty pattern to our human eyes is actually a detailed genetic brochure written in light. And as if the visual spectacle weren't enough, many species add a sonic element to their performance. The males produce vibrations through their substrata, both through specialized structures on their body and through the silk lines that he attaches to his perch. These vibrations travel through the ground into the female's legs and communicate information that complements what she's seeing. It's a courtship as a total sensory experience, multimedia entertainment packaged in a 5mm body. Now here's where things get interesting from a behavioral perspective. Female peacock spiders are extremely picky. They've been observed rejecting males for what seemed like no reason at all, rejecting them before the dance even starts, rejecting them mid-dance, rejecting them after what appeared to be a perfectly acceptable performance. Researchers have spent years trying to decipher the selection criteria, and the conclusion is disturbing, or reassuring depending on your outlook. The females might just be testing the male's persistence. They might be assessing his dance for subtle asymmetries that indicate genetic fitness. They might be evaluating the quality of his displays in ways we haven't yet understood. Or, and this is a theory I personally find most appealing, they might be simply difficult because they can be. In a species where males invest this much energy into courtship, females have the luxury of being selective, and selective they are. When a male is rejected, he has a few options. He can try again with the same female, performing a modified version of his dance. Or he can move to a new territory and hope for better luck elsewhere. Or if another male shows interest in his territory, he can fight. Though physical combat is relatively rare, reserved for situations where the stakes are high enough to risk injury. When a male is accepted, mating occurs quickly. The male transfers his sperm to the female via a specialized appendage called the pedipalps, and that's essentially the end of his contribution to the next generation. He might mate with multiple females over his lifetime, which typically spans only 1 or 2 breeding seasons total. Females, by contrast, can store sperm and produce multiple clutches of eggs, ensuring genetic diversity with each batch of offspring. The whole courtship process, from first approach to successful mating, can take anywhere from a few minutes to over an hour. Females have been observed watching multiple males in succession, comparing performances like judges at a talent competition. Only the best dancers get to pass on their genes. Status and conservation. This is where our story takes a slightly concerning turn. Despite their charm and their internet popularity, peacock spiders face significant challenges in the modern world. Habitat loss, climate change, and the general degradation of Australia's unique ecosystems all pose threats to these tiny performers. Most peacock spider species have extremely limited ranges. Some are known from only a single location, a single patch of bush where the right combination of soil, vegetation, and microclimate comes together to support a population. When that habitat is disturbed by development, by fire, by an invasive species, by a change in rainfall patterns, these populations can disappear practically overnight. Fire in particular is a double-edged sword for peacock spiders. Australia's ecosystems have evolved with fire. Many plant species actually require fire to reproduce. But catastrophic fires, the kind that are becoming more frequent and more intense with climate change, can devastate peacock spider populations that they have nowhere to escape. These spiders can't run from fire, they can only hide, and sometimes hiding just isn't enough. Climate change adds another layer of complexity. As temperatures rise and rainfall patterns shift, the sclerophyll habitats where the peacock spiders live are changing. Some areas that were once suitable are becoming too hot, too dry, or too seasonal. The delicate timings of peacock spider life cycles, emerging in spring, mating when flowers bloom, could be disrupted if phenological relationships fall out of sync. And yet there's reason for cautious optimism. Peacock spiders have a few things going for them that many endangered species lack. First, they're small. Actually, scratch that, they're tiny. While this makes them vulnerable to habitat destruction, it also means they can survive in small patches of suitable habitat that larger animals would ignore. A remnant of bushland, a roadside reserve, a garden that hasn't been sprayed with pesticide, all could potentially support peacock spiders. They are the ultimate urban wildlife, thriving in the margins of human-dominated landscapes if those margins are left relatively undisturbed. Second, they generate interest. Peacock spiders are, objectively speaking, adorable. Their courtship dances have been viewed millions of times on YouTube. Scientists like Jürgen Otto have dedicated careers to studying them. This attention translates into research funding, conservation advocacy, and public support for protecting Australian habitats. It's not always enough, but it's more than many obscure species receive. Third, we're still discovering them. New species are described regularly, which means we're still learning where peacock spiders live, how they behave, and what they need to survive. Every new discovery is an opportunity to identify habitat that deserves protecting before it's too late. Most peacock spider species are not currently listed as threatened, but this status could change rapidly if conservation efforts don't keep pace with habitat destruction. The challenge, as always, is balancing the needs of human development with the preservation of these irreplaceable ecosystems. It's a challenge Australia has been struggling with for generations, and peacock spiders are just one of countless species caught in the balance. So there you have it, the peacock spider in all its glory, a creature that evolved visual sophistication of a bird of paradise in a body smaller than your fingernail. A dancer whose moves are genetically programmed, yet individually perfected. A predator and a performer, a tiny monarch of the Australian underbrush. Next time you're in Australia, skip the obvious attractions for a moment. Find a patch of sclerophyll scrubland, crouch down in the dirt, and look closely at the world at your feet. You might just spot a peacock spider doing what a peacock spider do best, dancing like nobody's watching, because to most of the world, they're invisible. But they're not invisible to us. Not anymore. If you enjoyed this deep dive into the world of peacock spiders, we have a feeling you'll love our other videos too. Subscribe to What Is and hit the notification bell so you never miss a video. We've got other animals and other topics like science and music just waiting to be explored. Leave a comment below and tell us what animal or subject you'd like us to cover next. We read every single response, and your ideas help shape what we create. Thanks for watching, and see you next time.